Somewhere beneath a mountain of ice, less than 60 miles from a major American city, the ground is moving. Not violently, not in a way you would feel if you were standing on it, but instruments buried deep in the rock are picking up something scientists cannot ignore. A pattern of tremors, subtle and persistent, rising from a place that has been quietly building pressure for over 1,000 years. The mountain is Mount Rainier. And whether you have ever heard its name before or not, if you live anywhere near Seattle, Tacoma, or the Puget Sound region, this is a story that concerns you directly. Because Mount Rainier is not just another peak on the horizon. It is widely considered the most dangerous volcano in the continental United States, not because it is the most likely to erupt violently, but because of what happens to the people living around it when it does. This is the story of a sleeping giant, the historic earthquake swarm that shook it in 2025, the new technology racing to protect the communities below it, and what scientists actually know and don't know about what could happen next. To understand why Mount Rainier commands so much attention from geologists, you first have to understand what it actually is, and how it fits into the landscape of the Pacific Northwest. Mount Rainier rises to more than 14,000 feet, making it the tallest peak in the Cascade Range, and one of the most prominent volcanoes in North America. On a clear day, it dominates the skyline for the roughly 4 million people who live in the greater Seattle-Tacoma metropolitan area. Locals simply call it the mountain, as if there could be no other. It is beloved. It is photographed constantly. It appears on license plates, murals, and coffee mugs across the state. But beneath the postcard, beauty is a structure that volcanologists describe with words like hazardous, unstable, and primed. Mount Rainier is a stratovolcano, the same type of volcano as Mount St. Helens, Mount Fuji, and Vesuvius. Stratovolcanoes are built from layers of hardened lava, volcanic ash, and rock debris, stacked over hundreds of thousands of years through repeated eruptions. That layered structure gives them their classic, steep, conical shape. It also makes them structurally weaker than volcanoes built from a single, solid mass of rock. That weakness matters enormously when you add the next ingredient: ice. Mount Rainier is the single most heavily glaciated peak in the contiguous United States. More than 24 glaciers cover its slopes, holding an immense volume of snow and ice year-round. In isolation, glaciers are just frozen water sitting on a mountain. But combine glacial ice with a structurally weak volcanic edifice, and you get one of the most dangerous natural hazard combinations on Earth. Here is why that combination is so alarming to scientists. When a volcano like Rainier becomes active, even mildly active, even without a full eruption, heat rising from below can rapidly melt portions of that ice and snow. That meltwater doesn't just trickle downhill. It mixes with volcanic ash, loose rock, and debris to form a fast-moving slurry of mud, rock, and water known as a lahar. Lahars can travel at speeds exceeding 30 or 40 miles per hour, moving with the density and force of wet concrete. They can strip forests bare, destroy bridges and roads, and bury entire valleys under dozens of feet of debris. And here is the part that keeps hazard planners awake at night. Several of the river valleys that drain Mount Rainier's slopes lead directly into some of the most densely populated areas of Washington state. Communities like Ording, Puyallup, Sumner, and parts of the Puget Sound lowlands. Some of these towns sit directly on top of ancient lahar deposits from Rainier's past eruptions. In other words, the ground many people are living, working, and sending their kids to school on today was, at some point in the last several thousand years, buried by a lahar from this exact volcano. This is why USGS scientists don't rank Mount Rainier as dangerous because of the size of a potential eruption. Compared to a supervolcano, or even to some of its Cascade siblings, an eruption at Rainier might not be enormous in terms of raw explosive power. What makes it dangerous is the geometry of the disaster: ice, unstable rock, and tens of thousands of people living in the direct path of the valleys that would carry a lahar to their doorstep, potentially with only minutes of warning. Mount Rainier's danger is not theoretical. It is written into the very geology beneath the towns that surround it. Roughly 5,600 years ago, a massive lahar, known to geologists as the Osceola mudflow, tore down from Rainier's summit. This wasn't a small local event. It was catastrophic in scale, ultimately depositing debris across an area that today includes major population centers in the Puget Sound lowlands. Some of that ancient mudflow material stretched all the way to what is now Puget Sound itself, a distance of many miles from the summit. Since then, Rainier has produced numerous smaller lahars, some triggered by actual volcanic eruptions, and others triggered simply by large-scale collapses of its unstable, hydrothermally weakened rock, meaning a lahar doesn't necessarily require magma to reach the surface. The volcano's own internal heat and acidic groundwater have spent thousands of years chemically weakening the rock inside the mountain, turning solid stone into something closer to weak, crumbly clay in certain zones. That means even without a true eruption, a large enough earthquake or years of gradual weakening could theoretically be enough to trigger a collapse and a resulting lahar. Rainier's most recent confirmed eruptive period is believed to have occurred around 1,000 years ago, with some possible smaller steam-driven explosions as recently as the 1800s, though evidence for those more recent events remains difficult to verify conclusively in the geologic record. So, by historical standards, Rainier isn't overdue in any strict scientific sense. Volcanoes don't operate on fixed schedules, but it is absolutely considered active and capable by every agency that studies it. The United States Geological Survey lists it among the highest threat volcanoes in the entire country, not because an eruption is imminent, but because of the devastating consequences if and when one eventually occurs. For decades, Mount Rainier sat quietly in the background of public attention, closely monitored by scientists, but rarely making headlines. That changed in the summer of 2025. In early July of that year, seismographs planted across the flanks of the mountain began recording something unusual. It started as a cluster of small earthquakes beneath the summit, the kind of minor seismic chatter that volcanologists see periodically and don't typically consider alarming on its own. But instead of tapering off within hours, as these swarms usually do, the earthquakes kept coming, hour after hour, day after day. By the time the swarm eventually began to slow, scientists monitoring the data confirmed something remarkable. It was the largest earthquake swarm ever recorded at Mount Rainier since modern seismic monitoring began. Thousands of individual tremors were detected over the following days, the vast majority of them far too small to be felt by anyone standing on the surface, but significant enough, in sheer volume and duration, to represent a genuinely historic event in the volcano's monitored record. For the scientists at the University of Washington's Pacific Northwest Seismic Network, commonly known as PNSN, and their partners at the USGS Cascades Volcano Observatory, this was a moment that demanded close attention, though not panic. Earthquake swarms at volcanoes happen for a variety of reasons. Sometimes they are caused by the movement of magma or volcanic gases deep underground, a genuine sign of a volcano waking up. But far more often, especially in the Cascades, they are caused by shifting groundwater, hydrothermal fluid movement, or simple tectonic stress relief that has nothing to do with an approaching eruption. Throughout the swarm, officials were clear and consistent in their public communication. Despite the record-breaking number of earthquakes, there was no detected deformation of the ground surface, no unusual volcanic gas emissions, and no other signs that magma was actually moving toward the surface. The volcano's official alert level remained at normal, and its aviation color code stayed at green, as the lowest levels on their respective scales, throughout the entire episode. In other words, the mountain was rattling, but by every measurable indicator available to science, it was not erupting, and it was not showing the classic signature of an imminent eruption. Still, the sheer scale of the swarm was enough to prompt scientists to take an extraordinary step. In response to the historic 2025 swarm, and out of an abundance of caution, scientists carried out something that had not been done at Mount Rainier in decades, a helicopter flight directly through the volcanic gases venting from the summit crater in order to sample them directly. This kind of gas survey is one of the most direct ways scientists can check whether new magma is genuinely rising inside a volcano. As magma moves upward through the earth, it releases distinctive gases, carbon dioxide, sulfur dioxide, and others, in ratios that shift depending on how close that magma is to the surface. A sudden spike in certain gases, particularly sulfur dioxide, can be one of the clearest fingerprints of magma actively approaching the surface. The last time researchers had conducted this specific kind of direct aerial gas sampling at Rainier's summit was in 1998, nearly 3 decades earlier. The decision to fly it again, in the wake of the historic swarm, reflected just how seriously scientists were treating the event, even while publicly maintaining that the volcano's alert status remained normal. The survey's results were reassuring. Gas emissions measured during and after the flight were consistent with the volcano's long-standing, low-level background venting, the same kind of passive steam and gas release Rainier has exhibited for as long as it has been monitored. There was no elevated signature suggesting fresh magma was pushing toward the surface. Combined with the absence of ground deformation, this gave scientists strong evidence that the historic swarm, while remarkable in scale, was very likely driven by hydrothermal or tectonic processes rather than a genuine march toward eruption. Still, the 2025 swarm left a lasting mark on how Rainier is discussed publicly. For the first time in a generation, supervolcano headlines and viral warnings about an imminent Pacific Northwest disaster spread rapidly across social media, most of them wildly exaggerating what scientists had actually found. The 2025 swarm didn't just capture the attention of seismologists, it captured the attention of the internet. And, in the months that followed, that attention occasionally curdled into misinformation. In November of 2025, a viral report began circulating online claiming that Mount Rainier was once again showing a dramatic new spike in seismic tremor activity, the kind of language designed to suggest an eruption might be imminent. The story spread quickly across social platforms, generating exactly the kind of fear-driven engagement that thrives online. There was just one problem. It wasn't true. Scientists at the Pacific Northwest Seismic Network moved quickly to investigate the claim, and what they found had nothing to do with volcanic unrest. The erratic signal that had sparked the viral rumor was traced back to a single monitoring station near the summit known as STAR, one of the network's older analog stations, which transmits its readings via a low-power radio link. During periods of severe winter weather, ice can build up on the station's antenna, distorting the radio signal in a way that mimics the appearance of continuous ground tremor on the resulting seismic readout. In plain terms, what looked like the mountain shaking was actually the electronic equivalent of static on a car radio during a storm. Network officials emphasized that any genuine volcanic tremor would register clearly and simultaneously across multiple independent monitoring stations spread throughout the region, not on a single instrument affected by a known equipment quirk. It was a useful, if uncomfortable, lesson in how quickly fear can spread faster than facts when it comes to natural hazards, and a reminder that not every viral headline about new activity at a major volcano reflects what scientists are actually observing on the ground. That history is worth remembering because it's directly relevant to how any current or future reports about Rainier should be evaluated. The most reliable path to the truth isn't a viral post. It's the official, continuously updated bulletins issued by the USGS Cascade Volcanic Observatory and the Pacific Northwest Seismic Network, the two agencies actually responsible for monitoring the mountain around the clock. So where does Mount Rainier actually stand right now? As of the most recent official weekly update from the USGS Cascades Volcano Observatory, every volcano across the Cascade Range of Washington and Oregon, including Mount Rainier, Mount St. Helens, Mount Baker, Glacier Peak, and Mount Adams, remains at background normal activity levels. The alert level across the range is listed as normal, and the aviation color code remains at green, the lowest classification on the scale used to warn pilots and communities of potential volcanic hazards. Scientists do continue to note occasional small earthquakes beneath both Mount Rainier and Mount St. Helens, a completely typical occurrence for actively monitored volcanoes in a tectonically active region like the Cascades. Volcanic seismicity naturally waxes and wanes over time, and isolated small earthquakes, even in clusters, are not by themselves considered unusual or alarming. What scientists watch for is a specific combination of signals, sustained ground deformation, a shift in gas chemistry, and a particular pattern and depth of seismic activity that together would indicate magma is genuinely moving toward the surface. As of the latest reporting, none of those combined warning signs have been detected at Rainier. In short, the historic 2025 earthquake swarm was real, and it was the largest ever recorded at the mountain. It prompted an unprecedented level of scientific attention, including the first direct aerial gas survey of the summit crater in almost 30 years. But every line of evidence gathered during and after that swarm points to the same conclusion. This was very likely a hydrothermal or tectonic event, not the beginning of an eruption. The mountain remains closely watched, but officially calm. If there's a genuine new development story at Mount Rainier right now, it isn't a sign of imminent eruption. It's the dramatic expansion of the technology built to protect the people living in its shadow. For years, hazard planners in Washington state have understood a brutal mathematical reality. Because lahars can be triggered with relatively little warning and can travel at highway speeds down river valleys, some communities downstream of Rainier might have as little as 30 to 60 minutes, or in worst-case scenarios, even less, between the first sign of a major lahar and its arrival in populated areas. In response, the USGS has been steadily expanding a network of specialized lahar detection sensors positioned along the river valleys, draining Rainier's glaciers, the exact pathways any future lahar would be most likely to follow. These sensors are designed to detect the unique acoustic and seismic signature of a lahar in motion, the specific low-frequency rumble and ground vibration created by a fast-moving wall of mud, water, and debris, distinct from the signature of a normal earthquake or a passing truck. When these sensors detect that signature, they're built to trigger an automated alert chain within seconds, feeding data to the USGS and directly into Pierce County's official lahar warning system, which in turn is designed to activate a network of sirens and emergency alerts in at-risk communities like Orting, a small town built almost entirely within a historic lahar hazard zone. Local schools in the area conduct regular lahar evacuation drills, training children and staff to move quickly toward higher ground the moment an alert sounds, without waiting for further confirmation. This sensor network has been expanded and upgraded significantly in recent years, reflecting a broader push by federal and state agencies to close the gap between the moment a lahar begins and the moment communities receive a life-saving warning. It's a sobering reminder that even in the absence of any confirmed sign of an imminent eruption, officials are not waiting passively. They are actively building out the infrastructure needed to give people in Rainier's shadow every possible extra second of warning. It's worth pausing to walk through what scientists actually expect if, and it remains a genuine if, Mount Rainier does eventually erupt again. According to the USGS, a new eruption at Rainier would most likely begin with relatively modest steam and ash explosions, centered at the summit, driven by the interaction of rising heat with groundwater and ice near the crater. From there, activity could progress in a few different directions, depending on how much magma is actually involved. In some scenarios, the eruption might produce a slow-moving lava flow. In others, steep, unstable lava domes near the summit could partially collapse, generating fast-moving avalanches of hot rock, ash, and gas known as pyroclastic flows, one of the most immediately dangerous phenomena any volcano can produce. But regardless of exactly how the eruption itself unfolds at the summit, scientists are consistent on one point. The greatest danger to human life and property would almost certainly come from lahars generated by the interaction of eruptive heat with Rainier's extensive glacial ice. These lahars could travel down multiple river valleys simultaneously, potentially reaching populated lowland communities within roughly an hour or less of the eruption's onset. And in a worst case, a most severe scenario, some models suggest a large lahar could theoretically reach as far as Puget Sound itself, echoing the ancient Osceola mudflow of thousands of years ago. Crucially, scientists emphasize that a major eruption at Rainier would almost never arrive without warning. The USGS notes that eruptions are typically preceded by observable precursor signals, days, weeks, or even months of escalating small earthquakes centered beneath the volcano, measurable deformation of the ground surface as magma pushes upward, and detectable increases in volcanic gas emissions and ground temperatures. This is precisely why the 2025 swarm triggered such close scientific scrutiny, even though it ultimately didn't develop into anything more. Because these are exactly the kinds of signals scientists are trained to watch for, and precisely why continuous, round-the-clock monitoring matters so much. The takeaway from hazard experts isn't that an eruption is coming soon, it's that if one ever does begin, the data streaming in from Rainier's expanding sensor network is what would give surrounding communities the crucial extra minutes needed to reach safety. For the people who actually live around Mount Rainier, this isn't an abstract science story. It's part of daily life. Towns like Ording have grown up almost entirely within a mapped lahar hazard zone, built on the very ground once buried by ancient mudflows from the mountain looming above them. And yet, these communities continue to thrive, drawn by the region's stunning natural beauty, its proximity to Seattle and Tacoma, and its access to some of the best hiking, climbing, and outdoor recreation in the country. Local officials have worked to strike a careful balance, acknowledging the very real, scientifically documented hazard without turning daily life into a state of constant fear. Evacuation routes are marked with clear signage throughout at-risk towns. School drills are treated as routine, similar to fire or earthquake drills elsewhere in the country. Public information campaigns remind residents of the difference between routine seismic background noise, something Rainier experiences constantly, and the specific combination of signals that would actually indicate a genuine emergency. This measured, prepared, but not panicked approach reflects exactly what scientists want the public to take away from stories like this one. Mount Rainier is, unquestionably, one of the most closely watched and potentially hazardous volcanoes in the United States. Its history includes genuinely catastrophic events. Its geology all but guarantees it will erupt again at some point in the future. Geologically speaking, that's not really in question, but will erupt eventually and is about to erupt right now are two very different statements, and conflating them is exactly the kind of exaggeration that fueled the debunked viral rumors of late 2025. Perhaps the most reassuring part of this entire story is just how much dedicated, continuous monitoring is quietly happening beneath the surface of daily life in Washington state. The Cascades Volcano Observatory and the Pacific Northwest Seismic Network maintain a dense web of seismometers, GPS stations, and gas monitoring equipment across Mount Rainier and its sister volcanoes throughout the Cascade Range. This data streams in continuously, 24 hours a day, 7 days a week, feeding automated systems designed to flag any unusual pattern the moment it emerges. Weekly public updates are issued detailing exactly what's being observed at every monitored volcano in the region, providing a transparent, evidence-based counterweight to the kind of sensationalized claims that spread so easily online. This infrastructure represents decades of accumulated investment, expertise, and hard-won lessons, many of them drawn directly from the catastrophic 1980 eruption of Mount St. Helens, Rainier's Cascade neighbor to the south, which remains the deadliest and most destructive volcanic eruption in modern United States history. The tragedy of that event, and the scientific advances that followed in its wake, fundamentally reshaped how American volcanologists approach hazard monitoring, with Mount Rainier, given its unique combination of glacial ice and nearby population centers, consistently treated as one of the very highest priorities in the entire country. Helens, Mount Adams, Mount Hood, Mount Jefferson, the Three Sisters, Newberry, and Crater Lake among them. Every one of these volcanoes is monitored, and every one of them carries some degree of hazard for the communities nearby. But when the USGS ranks the relative threat level of American volcanoes, Rainier consistently lands near the very top of the list. Not because it is expected to produce the largest eruption, but because of a specific combination of factors that few other volcanoes share. Mount St. Helens, for comparison, is famous for the sheer explosive violence of its 1980 eruption, a lateral blast that flattened hundreds of square miles of forest and killed 57 people, making it the deadliest and most economically destructive volcanic event in modern U.S. history. But St. Helens sits in a comparatively less populated area, and its glacial ice cover, while present, is far less extensive than Rainier's. Mount Hood, looming over Portland, Oregon, shares some of Rainier's same hazard profile. Significant glaciers, a history of lahars, and a nearby major city, and it, too, ranks among the highest threat volcanoes in the country. But even Hood's ice cover doesn't match the sheer scale of what sits atop Rainier. What sets Rainier apart is this specific combination. It holds more glacial ice than any other volcano in the contiguous United States. Its internal rock structure has been extensively weakened by thousands of years of hydrothermal alteration, and it sits directly upstream from some of the fastest growing, most densely populated valleys in Washington state. Put simply, other Cascade volcanoes might match Rainier on any single one of these factors individually, but none combine all three quite the way Rainier does. That's the real reason it tops so many hazard rankings, and why any unusual activity there, like the 2025 swarm, draws such an outsized level of scientific and public attention compared to a similar event happening at a more remote, less glaciated peak. Given everything you've just learned, it's worth spending a moment on a practical question. If you live in the Pacific Northwest, how should you actually process headlines about Mount Rainier going forward? The honest answer from scientists is refreshingly simple. The single most reliable source of information will always be the official channels, the USGS Cascades Volcano Observatory's public updates, and the Pacific Northwest Seismic Network's bulletins, both of which are updated regularly and are built specifically to give the public an honest, jargon-light picture of what's actually happening beneath the mountain at any given time. These agencies have no incentive to downplay real danger. Their entire mission is public safety. But they also have no incentive to manufacture drama where none exists. By contrast, viral social media claims about sudden massive spikes in activity should always be treated with healthy skepticism until confirmed through those official sources, especially in light of the debunked November 2025 incident, where a piece of aging radio equipment icing over in a storm was enough to spark headlines implying an imminent eruption. That episode is a useful case study for the future. The more dramatic and urgent a volcano headline sounds, especially one spreading rapidly online without direct sourcing to USGS or PNSN, the more reason there is to pause and verify it against the official record before reacting. This doesn't mean the public should tune out entirely. Genuine, scientifically confirmed changes in Rainier's status, a shift to an elevated alert level, confirmed ground deformation, or a change in the aviation color code, are exactly the kind of developments worth paying close attention to, and worth taking seriously and immediately if they ever occur. The lesson isn't ignore volcano news. It's trust the instruments and the scientists reading them, not the algorithm deciding what gets pushed into your feed. So where does that leave us? Mount Rainier remains exactly what it has always been. A genuinely active, genuinely dangerous volcano, and one of the most carefully monitored geological features anywhere on Earth. It sits quietly above millions of people, a majestic, snow-capped backdrop to their everyday lives, and simultaneously, a slow-motion hazard whose full story is still being written by the ash, mud, and rock layered beneath the towns that surround it. The historic swarm of 2025 was real, remarkable, and worthy of the intense scientific scrutiny it received. It pushed researchers to fly through volcanic gases for the first time in decades, and to expand an already impressive network of LAHAR detection sensors, protecting the valleys below. But it did not, as of every official measurement available, signal an imminent eruption. The mountain, for now, remains at its lowest alert level, quietly rumbling in the background the way it always has, while an army of instruments keeps a careful, unblinking watch. That's really the heart of this story. Not fear, but respect. Respect for the raw geological power sitting quietly above one of America's most beautiful regions, and respect for the scientists working around the clock to make sure that if this sleeping giant ever truly begins to stir, the people living in its shadow will have the warning they need. Because when it comes to a mountain like Mount Rainier, the real headline was never about panic. It's about preparation. So the next time you see a dramatic headline claiming the mountain is waking up, take it as an invitation, not to panic, but to actually check in on what the real science says. Visit the official USGS Cascades Volcano Observatory updates. Look at the current alert level. Notice whether the story is sourced to actual seismologists or simply to a viral post with no attribution. That single habit, pausing to verify before reacting, is, in its own small way, exactly the kind of preparation this story has been about all along. Mount Rainier isn't going anywhere. It has stood watch over this corner of the country for hundreds of thousands of years, and it will likely stand for hundreds of thousands more, occasionally rumbling, occasionally venting steam, occasionally reminding everyone beneath it that it is very much alive. The scientists tracking it aren't waiting for a disaster to take it seriously. They already do, every single day, through instruments that never stop listening. And that, in the end, is the real story behind the headline. Not a mountain on the verge of catastrophe, but a community of researchers, engineers, and emergency planners quietly building the tools to make sure that whenever this sleeping giant does eventually stir for real, the people living in its shadow won't be caught by surprise.